All right, in this video, we want to review solving radical equations. To solve a radical equation, the first thing that we want to do is we want to isolate the radical. So we want to get that radical symbol all by itself. If there happens to be two radical symbols, then I need to get one radical on each side of the equal sign. Okay, so I'd isolate it on both sides. After we've done that, we're going to use the opposite operation. We're going to have to bring in some exponents here to be able to do this. So for example, if I have the square root, the inverse operation of that would be that I would need to square the function to make it cancel. If I had a cube root, the inverse operation would be to cube it to get the x. If I had a fourth root, the inverse operation would be to raise it to the fourth power. So hopefully we kind of get the idea. The inverse operation using the exponent of whatever my radical value is. Okay. So once I've done that, then I'm going to continue to solve for my variable. Okay. And then I'm going to check for those extraneous solutions. Remember, an extraneous solution means that I solved the equation, I got an answer, but when I went back and I plugged it into the original equation, I don't get a true statement. It would be something like I got the answer to be 7. So I go back and I plug 7 in and I get something that says 3 equals 9. No, it doesn't, right? So that would mean I have a false statement. So I don't get anything true. So even though I solved and got that number 7, it's extraneous solution because it doesn't check back out. So I have to remember to check my solutions when we're looking at radicals. All right, so let's look at some examples. All right, so we're going to work through some examples here. Remember, my first step is to isolate that radical. So I'm going to move my 7. I'm going to divide by my 2. Now I've got my radical all by itself. So what I want to do is I want to use my inverse operation. So I want to bring in the exponents that is going to get rid of a square root. So to get rid of a square root, I need to square both sides. Okay, so that's going to make my radical go away, which will leave me with x plus 1 equals 2 squared is 4. Remember, this is squaring it. It's not multiplication, it's squaring. All right, so then my last step is I'm going to continue to solve. So I would subtract my 1 here. So I get x to equal 3. Well, I think that I get x to equal 3. But remember, we said that I always want to check my solution. So I'm going to take x equaling 3 back to my original equation, and I'm going to solve it. So 7 plus 2 times 3 plus 1. It's supposed to equal 11. So that's the real question. Do I equal 11 or not? Okay, so let's plug it in. 3 plus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. 4 plus 7 is 11. I do indeed check out. So 3 is a solution. Okay. If when I plugged 3 back in, I did not get 11, then I would have said it's extraneous, therefore I have no solution. Okay, so just so you can kind of see how that might happen. All right, let's look at another example. Again, I want to start by isolating my radical. So I'm going to move this 6, subtract my 6 here. My radical is now by itself. So what I want to do now is I want to get rid of a cubed root by cubing it. Okay. So I've got x minus 4. And remember, that's not 3 times 3. It's 3 cubed. So I get 27 here. Then I'm going to continue to solve. So I'm going to add that 4. So x is going to equal 31. So again, I think that x equals 31. I'm not sure. So I want to go back and I'm going to go plug it in. So I'm going to say 6 plus the cubed root, 31 minus 4. And the question is, do I really equal 9? Okay, so let's do it. 31 minus 4 is 27. The cubed root of 27 is going to be 3. 3 plus 6 is 9. So yes, indeed, 9 equals 9. So 31 is a solution. Right? Moving on to the next one. I want to isolate my radical. So I'm going to move my 5. Now that my radical is isolated, I want to get rid of the fourth root by raising it to the fourth power. Okay, so that's going to cancel off my radical. 2x minus 1. That's going to equal 16. Then I'm going to keep solving. So I'm going to add my 1. And divide by my 2. So I think that that's my answer. So I'm going to go back and I'm going to plug it in. So I'm going to have the fourth root of 2 times 17 over 2. And you can use the decimal, it doesn't matter. The question is, do I actually equal 7? So 2 times 17 over 2 is just 17. 17 minus 1 is 16. The fourth root of that is 2. 2 plus 5 is 7. So 7 does equal 7. So 17 over 2 is a solution. So I wanted to show you one that it's okay to get a weird answer like a decimal. It is perfectly fine. I can still go back and plug it in and get the solution to work. All right? Let's look at another one here. Now this one looks a little bit different. You're like, oh, well, where's the radical, right? So I need to remember my exponent rules that say, well, if I have a 1 over 2, that's the same as saying the square root. So I'm going to rewrite this first. So one thing to remember is those exponent rules. This time it was a 1/2. What if it was a 1/5? Well, then it would be the fifth root of x plus 2. Say next time it was the 1/9. Then it would be the ninth root of x plus 2. Okay, so remember, if I raise and I have an exponent of 1 over something, it's just a radical. Okay, so now that I can remember that it's a radical because it looks correct now, I'm going to isolate that radical. So I'm going to move that 13 over. Then I'm going to divide by that -1. Okay. Now I need to get rid of that square root by squaring it. So I get x plus 2 equals 9. I'm going to keep solving it. So I get x to equal 7, or I think that it's 7. So I'm going to take that back up there and I'm going to solve it. Make sure that I really get 10. Okay, so I'm asking, do I actually get 10? So I've got 7 plus 2 is 9. The square root of 9 is 3. 10 minus 3 is indeed 10. So yes, x equals 7 is the solution. Okay? Okay, so you're probably thinking, okay, I got it. No big deal. Well, let's just make sure. Okay, let's do a couple more. Just humor me, make sure we've got it here. Okay, remembering that my steps are to make sure that it looks like a radical. Right, so raising it to the 1/4 is a fourth root. Now I need to isolate that radical. So I'm going to subtract my 12. So I'm going to exponentiate, or I'm going to get rid of that radical, right? So I'm trying to get rid of a fourth root, so I'm going to raise it to the fourth power. All right, so I'm going to get x minus 1 equals 81. I'm going to keep solving, so I'm going to add my 1. So I think 82 is a solution, so I'm going to go back and plug it in. So I get 12 plus the fourth root of 82 minus 1 equals 9. Okay, so 82 minus 1 is 81. The fourth root of that is 3. 12 plus 3, that is 15. That is not equal to 9. So this is actually extraneous, which means that 82 does not work. So my actual answer is no solution. Now, you're going to kind of get mad at me here for a second because I really didn't have to do all that work. If we remember, and it's been a while, so you might not, but if we remember, any even exponent, okay, which means I had an even radical. So if I have an even radical, I cannot equal a negative number. So an even radical cannot equal negative. Okay. Now, in the very beginning, I didn't know that was going to happen, right? Because I had an even radical and I was equal to a positive. So I started solving. And I solve it and I solve it. And then here, this step right here, I actually didn't have to do anything else after this step. Okay? Because there's no way that I could take the fourth root of anything and get something negative. Okay? But most of us just get kind of caught up in the steps and we're just like going through. Let me do all my steps that I'm supposed to do. If you remember to check your solution like we did here, when I go back and plug it in, it's easy to see that it doesn't work. So I can get to that no solution both ways. All right. So I just want to kind of throw that one in there to make sure that we are checking our solutions. All right. So let's look at this next one here. Okay. I notice on this one I have 2 of my radicals. Okay. So I need to make sure that they're on either side of the equation, which they are. So I've already technically isolated my radical. So the next thing to do is to get rid of that square root. So to get rid of a square root, right, I would square both sides. Well, when I square both sides, it's going to make both of my radical symbols go away. So if x plus 5 equals 2x plus 1. So now I'm just solving a regular equation. Right, so I need to get x's all on the same side. Move that 1. And I think that x equals 4, but I'm not sure. So I actually want to go ahead and go back and check, because as we saw in the last one, you know, we're never really sure until we check. So let's go back and plug in. So I've got the square root of 4 plus 5, and I want to see, does it equal the square root of 2 times 4 plus 1? So let's see, 4 plus 5 is 9, so I've got the square root of 9, which is 3. 2 times 4 is 8. 8 plus 1 is 9, so I've got the square root of 9, which is also 3. So yes, indeed, they equal. So x does equal 4. Right? Let's try one more like that one. Make sure we are okay when I've got radicals on both sides. And, you know, honestly, it doesn't matter if I'm squaring them, cubing them, fourthing them, fifthing them, whatever. When they are on both sides, both of those radicals are going to cancel. Okay, so I'll be left here with 3x plus 2 equals 5x plus 8. So let's keep solving here. I'm going to get my variables on the same side, so I'm going to move this 3x. Then I'm going to move that 8. Divide by my 2. So I think that x equals -3, but I'm going to go back and plug it in just to make sure. So I'm going to go back and plug in. I end up with 3 times -3 plus 2. Does that equal the square root of 5 times -3 plus 8? Okay. So I've got -3 times 3, which is -9 plus 2, square root of -7. 5 times -3 is -15 plus 8, square root of -7. So those are actually equal. Even though you're like, whoa, I can't have the square root of a negative. Okay, doesn't really matter. They are the same. I'm not asking, oh, does it make sense? I'm asking, do I get the same answer? And I do. So x is going to equal -3. Right? So last one. I'm going to isolate my radical. I'm going to get rid of that cubed root by cubing both sides. Subtract that 1. Divide by 3. So I think that x is 333, but I'm not sure. So let's go back and plug it in, make sure we've got it. So I'm going to take the cubed root, 3 times 333 plus a 1. Subtract 7, and the question is, do I actually get 3? Okay, so let's do it. 333 times 3 is 999, plus 1 is 1,000. Cubed root of that is 10. 10 minus 7 is 3. It checks out. So I see that I could have a big number, I could have a negative number, I could have no solution. And then on the examples on the other one, on the other side, I noticed, oh my gosh, I could have a fraction. So yes, anything is possible here. I just have to make sure that I go back and I check those solutions.